Welcome to the Quick Start video guide for setting up E1 and V.35 serial communication link. The objective is to set up serial ports of the OKAPI router to work over an E1 and a V.35 line. The sequence of steps used in this demonstration are: set up the serial interface by selecting the encapsulation mode and assigning IP addresses. Further, depending on the type of serial line being utilized, that is either E1 or V.35, we use additional setup commands. For instance, time slot and CRC for E1. Verify settings through show interface and by pinging the pair. Configure static route to network 10.20.0.0/16 and also check routes through the show IP route command. We further validate the serial links by pinging network machines and using traceroute command. The OKAPI router can support any number of synchronous serial interfaces. Each serial link can be either an E1 or a V.35 link. Again, each link can work with PPP and HDLC encapsulations. To showcase a serial communication over both the lines, we will use two network scenarios. In the first scenario, the serial link between router A and router B will be established for a V.35 line. The IP of interface S1 of router A is 10.5.5.5/32 and the address of the pair is 10.5.5.6/32. The second scenario pictorially appears to be the same as the first one, except that we now establish an E1 line between router A and B via interface serial 0. The address assigned to that interface is 10.1.1.1/32 and to its pair 10.1.1.2/32. Lastly, in both the scenes, router B is connected to network 10.20.0.0/16 over fast Ethernet 0. We will now start with the hypothetical scenario of scene 1. Logging to router A, we begin by configuring serial interface 1 with an encapsulation type for communication over the serial link. The possible encapsulation methods are raw HDLC, Cisco HDLC and PPP. Out of these, we use Cisco HDLC. Next, we assign the IP address. And finally, bring the interface up by no shut. The same can be verified by running show interface command. From the command output, one can see that the interface serial 1 is up and the pair IP is 10.5.5.6. The connectivity to the pair will now be verified by ping. Now, let's configure a route to network 10.20.0.0/16 with the serial interface as our gateway. We now run show IP route command to verify the static route configured previously. From the command output, it is evident that route to network 10.20.0.0/16 is via interface serial 1. This can be verified by pinging machines on the same network. We first ping 10.20.50.239. After that, we use traceroute to see the routes to machine with IPs 10.20.50.251 and 10.20.50.50. From the command output, it is conspicuous that packets are routed through the serial pair, that is 10.5.5.6. Proceeding to the second scenario, refreshing network diagram for scene 2. Here, serial link is established over E1 line by using serial port 0 of router A and B respectively. We start with setting up serial interface 0. Again, the possible encapsulation methods are raw HDLC, Cisco HDLC and PPP. Out of these, we use PPP encapsulation. Setting up time slot for even frame. Even frame has 32 time slots, and here we are using all available slots, that is 1 to 31. Time slot 0 is not used for data. Also, time slot 16 can be used either for control signals or for data. We want to use it for data, so we execute TS16. This specifies that time slot 16 is now used for data. Further, we enable CRC generation and verification for even link. Assigning IP address to the interface. Finally, we bring the interface up by no shut. The status of our configured interface can be verified by running show interface command. From the command output, one can see that interface serial 0 is up and the pair IP is 10.1.1.2. The connectivity with the pair router can be verified by pinging it. Now let's configure a route to network 10.20.0.0/16 with the serial interface as our gateway. To verify the route, we use show IP route command. From the command output, we can see that a route to destination network 10.20.0.0/16 via serial 0 has been added. The same can be verified by pinging three machines on network 10.20.0.0, pinging 10.20.50.239. Now we use traceroute to see route to machines 10.20.50.251 and 10.20.50.50. One can see that the packets are routed via 10.1.1.2. At this note, we also conclude our presentation.